Hi guys, and welcome to this video on adding and subtracting algebraic fractions. Goodness gracious me, sounds complicated, yes? No, my name's Darren Maths Guru, really good to see you again. Hopefully this is not the first time you've seen my videos. If it is, can you do me a favor, like, subscribe, tell your mates, TikTok, Instagram, even tell your teachers. I would be deeply, deeply grateful. The style of these videos is I try and make it as easy as I possibly can for you. All right, by lots of worked examples, lots of theory, and just breaking it down in a sort of humorous way. Hopefully, if you can and you enjoy it, like the video. It really, really does help. And also make a comment if you're watching it on YouTube. All right, so adding and subtracting algebraic fractions, and you have already melted, haven't you? You've gone fractions, stop, delete, unsubscribe, and leave. Don't. Fractions really are not as bad as you think. And okay, while you may have disliked them last year and the year before and the year before that and the year before that, you may now suddenly be in a way that your brain goes, do you know what? I'm going to give this another chance. It's not like you drive a car, is it? You stall it the first time you get out and go, I'm never driving again. Give it a go. See what happens. Right, I'm going to recap fractions. And at the moment, I'm just going to add and subtract fractions with the same denominator. Right now, if you remember, a fraction, for example, a half, has a numerator and a denominator. All right, numerator and denominator. Why is that useful to me? Don't know. I just thought I'd write it. When we add fractions, all right, when you add or subtract fractions, the rule is the denominators must be the same. And yes, I did write the same. It's not my problem. I'm a maths teacher, not an English teacher. Leave that to the English department to sort out. All right, must be the same. When that is true, we can add or subtract fractions, right? So only add or subtract when true. All right, so again, these are me making notes, and you can download these from mathsguru.com. Head over there and sign up, absolutely free. Yeah, so only add or subtract when true. This is fractions. So here's an example. If I have 1/3 plus 2/3. Now, first thing you do again, are the bottoms the same? They are the same. And so in which case, I can add these together. Now, my advice is to always write one long division sign. Because what you then do is when the bottoms are the same, you just copy the tops on. Now, why am I doing this? Because believe it or not, if you can do this, you can do algebraic fractions with no trouble whatsoever, I promise you. So 1 plus 2 is 3, divided by 3. And if you watch my previous video, any number divided by itself is equal to 1. And you would have known that. I mean, you could have imagined this as cakes. 1/3 of a cake and 2/3 of a cake mean you got a whole cake. And I'd like a slice, please. All right, so that is an example. Let's do another example. Let's do 1/5 plus 3/5. Now again, do the check. Are the bottoms the same? Yes, they are. So we can now write one long divisor. You don't add the bottoms. The number of people who add the bottoms as well, you don't, right? Please, please, please do not add the bottoms. You just add the tops together. So the 1 plus the 3, which gives me 4/5. And there is my correct answer. Now, obviously, life becomes a little bit more interesting when the bottoms aren't the same. So, for example, if I had 2/5 and 1/10, they are not the same. Yes, that 5 and that 10 is not the same. We can only add them when they are the same. And generally speaking, we always want to make the bottoms the same number. And it's normally the higher number if it can. So in this particular instance, I'm going to try and make both of them have 10s on the bottom, because then I can add them together. We can only add and subtract when the bottoms are the same. And so again, if you remember this from school, because I haven't changed the bottom number of that fraction, I don't change the top number. All right, so that stays as a 1. Let's rub that out so that it doesn't get confusing. But what I have done is I've actually changed the bottom number there. I have in fact made it twice as big. So I've made the bottom number twice as big. And when I do that, because fractions have to stay balanced, if I make the bottom number twice as big, I make the top one twice as big, and so that is the same. So what we're really saying is that 2/5 is the same as 4/10, and we know that. We've done this, again, another video, previous topic. Now that the bottoms are the same, I know that I can add them together. So 10, 4 plus 1 gives me 5 on 10. Would I leave that as my answer? Nope, because I can cancel that down. 5's into there once, 5's into there go twice, and so we have a half, right? So that was a complicated example because it involved cancelling down as well. But where the bottoms are not the same, we need to make them the same. And again, this is only true for addition and subtraction. So now let's throw in some algebra. What would happen if I have 2x on 5 plus 3y on 5? Can I add these together? Absolutely, because again, the foundation work we've taught you shows you that we can add fractions when what is true? When the bottom of the fraction is in fact the same, and they are the same. So if you remember, I write a long line with the 5 on it because they are the same, and what do I do to the top? I add them together. Now, if you've watched my previous video, we'll be looking at these going, well, okay, we've got two terms. Are they like terms? Well, they've got an X and a Y in it. They're not the same. There's 2 xylophones and 3 yaks. Can I add those together? No. So in fact, that is my final answer. And again, you guys will look at this going, but it needs to be a number, doesn't it? It needs to be a number. No. We're going to start to move away from having numbers, and that is perfectly acceptable. And in fact, the right answer for that question there. Brilliant. All right, so let's do, e.g., let's do 4x on 6. Nope, let's change that one. 7 plus 3x on 7 as well. Let's make them the same. All right, so again, they are the same. Can we add them together when they're the same? Absolutely. So I draw my line, and there is my 7. Copy on the top, 4x plus 3x. Hold on a moment. Now we've got to do our check. We don't just leave it there. We have to keep checking now. Extra stages. Are these here like terms? I should cocoa they are. I've got 4 xylophones and 3 xylophones, which means I have 7 xylophones divided by 7. And I'm going to put a set of equal sign there and say, can we do anything here now? Yes, because again, it goes back to a previous video. Notice how this is all building on top of each other. And we know we've got a number on the top and a number on the bottom that can be divided. 7's into there go once, 7's into there go once. So I have 1 times x on the top and 1 on the bottom. And we know that any fraction divided by 1 is in fact a whole number. And so my answer there just becomes x. Now, I know again, this might seem a bit like, do questions, have a go, see what you come up with, make mistakes. It is not bad to make mistakes and get things wrong, I promise you. Another example, let's do 3x on 5 plus 2x on 10. Oh no! The bottoms are different. The bottom's different. Well, they might be different, but we've met this before. We've met the same idea before. So what am I going to do? I need to try and make them both go into the same number, right? So the highest common factor of 5 and 10 is in fact 10, and we're using highest common factor now because that's going to come in important later. Right, so this number here was 10, that stayed as 10, so the top stays as 2x. Remember, if you don't change the bottom number, then you don't have to change the top number. But this 5 has turned into a 10, and remember, when we're doing that, we do it multiplication. What do we do? 5 to 10 times by 2. So now I'm going to have to do 3x times by 2. Well, to go to another video, we know that's 3 times x times 2. We know that we've expanded. Then what do? We sort. So we put the numbers together, 3 times 2 times x, which gives me 6 times x, or 6x. So we now know that the 3x's has become 6x's on the top. All right, so what do we do now? Can we actually add these together? I'm going to move my working out over here. So yes, I've got all over here 10 because the denominators are the same. So we know we can add these together. So I get 6x plus 2x. Is that my final answer? No, because I've got some like terms that I can add together. So 6x plus 2x is 8 xylophones on 10. Am I finished? No, because you always need to check whether you can cancel down. And as it is, we can cancel down as well because we've got an 8 and a 10 that are divisible by 2. So 2's go into the 8 4 times, 2 go into the 10 5 times, I get 4 times x on the top, I get 5 on the bottom, and ladies and gentlemen, that is my final answer. Now I could do thousands more examples. I don't know how long this video is at the moment. What is it, 10 minutes and 40 odd seconds. Right, let's do a few more examples from the Cambridge textbook. All right, so looking at this one here, are the bottoms the same? No. Okay, so we've got to do something. Now, there's no point here in turning them both to 5s. Why? Because there is not an easy way to turn 3 into 5. So that's no use to me. So again, if you remember what we did before, we would need to look now at finding the lowest common multiple, highest common factor, whatever. Right? What number do 3 and 5 go into? For 15. Yep. So I'm actually going to make them 15s. So splitting that into 2 fractions, that's going to be a 15 on the bottom, that's going to be a 15 on the bottom, and there's a plus in between. All right, so that's the denominator. That's what we want for the denominator. Now we're going to look at changing. So I'm going to do the second one first. The 5 has changed into a 15. How? It's 3 times bigger. I've times it by 3. So when I times the bottom by 3, I have to times the top by 3. So I've got 2 apples. I want 3 times that. Well, I've got 2 apples times by 3. I've got 2 apples, another 2 apples, another 2 apples, 6 apples. So that becomes 6a. And again, you could have known that because the 2 times the 3 becomes a 6. So that's the first one. What about the next one? So how have we turned 3 into 15? 3, 6, 9, 12, 15, up times by 5. So we now have to multiply the top of this fraction by 5. So I now want to do 4a times 5. Well, again, we know that we got the 4 and the 5 is 20. So that's going to give me 20a. Ooh. Are the bottoms the same now? They are indeed. So I write one fraction with the 15 on the bottom because that's the same. I'm going to write 20a plus 6a. I'm going to write my working out, which gives me 26a on 15. And you're going to turn around and say, but can that cancel down? And I'm going to say to you, I don't think you can at this moment in time because there's not a number that divides into 26 and 15. And so there is my final answer. Now, all of these have been additions. Let's do a subtraction. A on 6. Minus b on 9. So this is just a minus sign. It works in exactly the same way. Okay, can 6 divide into 9 in a whole number of ways? No. So we need to try and find a number that both 6 and 9 will divide into, or in fact, the first number. 9, 18, 27, 9, 18. 18 works because 6 goes into 18. So I'm going to make these 18s. So following the rules before, that 9 has turned into an 18. How? By timesing by 2. So if I've got 1b on the top and I'm taking 2, I want 1 banana, so I've now got 2 bananas. That becomes 2b on the top there. Okie dokie. Right. What about the next one? I've got 6 turned into 18. So it's 3 times bigger on the bottom, 6, 12, 18. So the top has to be 3 times bigger as well. So I've got 1 apple. I want 3 lots of, it's 3 apples. 3 apples. So the bottoms are now the same. So I can now write one sign with an 18. I've got 3 apples minus 2 bananas. Can I simplify that? Nope. Why? Because the apples and bananas are not like terms. I've got apples and bananas. I've said apples and bananas. I'm not saying I can't take away bananas from apples. It doesn't make any sense. And so, ladies and gentlemen, there we go. That's my final answer. And again, that's pretty much it. So there are a lot of examples here. And again, rewind the video, have a look, have a go, try and do it on your own. Do some questions from a textbook, get them wrong, ask for help, because that's how you're going to learn. I promise you. Yeah, I hated maths at school with a passion. And now here I am doing maths videos. Why? Because I persevered. All right, let your mates know, like, subscribe. Otherwise, hopefully I'll see you in another video. Take care, guys. See you soon. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.